manufacture of ammonia by Habers process. In this we take nitrogen and hydrogen. Nitrogen we get from fractional distillation of liquid air, and hydrogen the source is from water gas or from natural gas. Water gas we prepare by Bosch process. Okay, so that's how we get hydrogen. So these are the sources of the reactant which is used for Habers process. Now nitrogen is taken 1 volume, hydrogen is taken 3 volume, and it is passed into a chamber which is called compression chamber. There the reaction, the gases are compressed, and the pressure involved is above 200, okay, above 200 atmosphere. And this is then passed into a catalytic chamber. There catalyst is placed. Catalyst used is finely divided iron, okay. The finely divided ions, why we are using? We can use a piece of iron also, but we are using finely divided iron because it increases the surface area. So surface area, when it increases, efficiency of the catalyst also increases. So that's the reason why we are using finely divided iron. And also a promoter is used, that is molybdenum. Okay, molybdenum is used as a promoter here. Promoter's action is it increases the efficiency of the catalyst, which is iron. Okay, so that is the role of promoter. And now it is passed into another chamber, where now here the reaction happens, that is nitrogen and hydrogen combines to at this temperature 450 degree to 500 degrees Celsius and about 200 atmosphere pressure in presence of catalyst and the promoter. It combines to give ammonia gas. Okay, so ammonia is formed, and that is passed into another chamber called condensation chamber. Here condensers with cooling pipes are there. Here condensation happens. Now 3 gases are there here. What are there? Remaining amount of nitrogen, remaining amount of hydrogen gas, and ammonia which is formed. So these 3 gases coming into the this condensation pipe. Okay, here when it is condensed, ammonia gas will liquefy first. Okay, ammonia will liquefy first, and it will be liquefied into liquid ammonia. Okay, and the remaining, the gas, that is nitrogen and hydrogen, which is unreacted, that nitrogen and hydrogen is again passed into compression chamber. So it is recirculated. Okay, it is again recirculated from condensation to compression. Okay, and now we got liquid ammonia. Okay, so this is how we get ammonia by Habers process. Here what we have to remember is the reaction is favored by low temperature. Why it is favored by low temperature? Because it is exothermic reaction, heat is evolved. So if you are supplying high temperature, it will be affecting the reaction. Reaction will go in the backward direction. So in order to move the reaction in the forward direction, we have to give a low temperature. But we can't keep too low, because the reaction should be in optimum temperature range. So that is taken as 450 to 500 degrees Celsius. Now second factor which helps in the formation of ammonia is high pressure. Okay, because we just look at the molecules involved in the reactant. 1 molecule of nitrogen is combining with 3 molecules of ammonia. So total reactant is 4. 1 plus 3, 4 is there. Now look at the product form, only 2 molecule is formed. So what is happening? 4 is changing to 2. That means it is getting compressed. Okay, volume is decreasing. So when it is volume is decreasing, that means pressure should be increased. Wherever we know that when pressure is increased in a container, if there is gas, and if you are using high pressure applied, the gas volume get compressed or volume get decreased. So when volume is decreased, that shows pressure is increased. Okay, so high pressure favors the formation of ammonia. Now the third factor which helps in the formation of ammonia is catalyst and the promoter. We have to use, to speed up the reaction, we have to use iron as the finely divided iron as the catalyst, and a promoter should be used. Okay, promoter like molybdenum or aluminium oxide can be used, which increases the efficiency of the catalyst. Okay, and another factor which we have to see is, since the reaction is exothermic, the heat evolved further maintains the temperature. Since heat is evolved, we need not have to heat further. Initially we give the heat and then we can stop the heating because heat is evolved. That heat keeps the reaction move in the continuous process. Okay, it goes on. So that is enough for the further reaction to proceed. External heating is therefore not required after the reactants are initially heated. And here also one thing to remember is purification of nitrogen and hydrogen is necessary, as impurities, like when we take nitrogen and hydrogen, it should be purified form. Why? Because impurities will be there in the nitrogen and hydrogen. Impurities like carbon dioxide, carbon monoxide, traces of sulfur, then hydrogen sulfide, so on can be there in the reactants. Okay, that will act as a catalytic poison. Okay, that will decrease the catalytic effect. Okay, that will decrease the rate of the reaction. So we have to eliminate or get rid of all these impurities. What are they? Carbon dioxide, carbon monoxide, traces of sulfur compounds, hydrogen sulfide, etc. should be removed because they act as poison to the catalyst, or they act as catalytic poison. So efficiency is increased by taking pure nitrogen and hydrogen. Okay, so these are the things which we have to remember in the preparation of Habers process.